Hello and welcome back to this course, covering the exam topics for the JNCIS-SP certification. In this section of the course, we're reviewing Layer 2 switching and VLANs, where we're covering Layer 2 switching mechanisms and Ethernet switching configurations in JNCIS. In this lesson, we'll be working through a few lab exercises to demonstrate the configuration and monitoring of Layer 2 switching on JNCIS. Additionally, we'll cover a couple tips and tricks that you can use to help speed up your device configurations and impress your coworkers. The format of this lab demonstration lesson will be that we'll first review the diagram of the lab we have set up. Next, we'll step through the instructions and goal of the configuration we'll be applying, and the verification we'll perform to validate our configuration is functioning as expected. First, before we jump into the live devices and do some configuration, let's review the topology we're working with. In this topology, we have two switches, SW1 and SW2. SW1 has three routing instances configured, VR11, VR12, and the default routing instance. There's a single interface in each routing instance. GE001 is in the default instance, where FE002 is in the VR11 instance, and FE003 is in the VR12 instance. This particular configuration is rather unusual in that the interfaces in all three instances are configured as routed interfaces with IP addresses in the same broadcast domain. Above, we have SW2 with these same interfaces connected to SW1. GE001 on SW2 is connected to 001 on SW1, 2 is connected to 2, and 3 is connected to 3. All three interfaces on SW2 are to be configured as switch ports in the same bridging domain, or VLAN, the default VLAN. Since I do not have two EX switches available to configure this lab, we'll be using two physical SRX devices, an SRX210 and an SRX220. It should be noted that the SRX210 is a platform which provides 2 gigabit Ethernet interfaces and 6 fast Ethernet interfaces, whereas the SRX220 provides 8 gigabit Ethernet interfaces. Because of this, we'll be referencing FE interfaces sometimes on the SRX210 and GE interfaces on the SRX220. The SRX platform is a multifunction device which performs routing, firewalling, and switching functions. These are great little devices for lab environments since they support so many functions and configurations. And the older models are typically inexpensive and readily available through various online shopping platforms. Now that we've reviewed the topology, let's review our configuration goals before we get started. These are the steps we'll be following through our lab demonstration. In this section, we'll be configuring Ethernet switching on the three interfaces on SW2, both individually and as an interface range. We'll then validate that the interfaces in each routing instance on SW1 are reachable from the default instance, confirming that the traffic was bridged successfully between the interfaces on SW2. In the last section of the lab, we'll be configuring static MAC address entries in the Ethernet switching table. We'll review the Ethernet switching table's contents before clearing it, configure these static table entries, and review the contents of the table again to validate that these static entries are shown as expected. So, without further ado, let's jump in and get started. On each node, SW1 and SW2, we just have a bare-bones configuration to start with. We have a user configured, SSH is enabled, we have the interface configurations with static MAC addresses configured on the physical interfaces to more readily identify the interfaces in the Ethernet switching table, and a static default route for management access. And since these switching functions are being configured on SRX devices, they have been placed into packet mode instead of flow mode. Same for SW2. We have a management address configured and a bare bones configuration. However, we have no interfaces configured currently, except for one we're using for management access. We'll start off by entering configuration mode and configuring GE002 Unit 1 with a protocol family. Here, we see the protocol families available for configuration. We'll select the Ethernet switch family. Now, the Ethernet switching family is not actually available on any logical unit except 0. So let's use a configuration trick for quickly moving our Ethernet switching configuration to Unit 0. We can use the rename command to move the configuration from Unit 1 to Unit 0 more easily. Now that this interface is configured for Ethernet switching, we'll need to set it as an access port on the default VLAN. Here, we've made the port a member of the default VLAN, and we'll set it as an access port so that traffic on the default VLAN will egress untagged, and untagged traffic ingress will be interpreted as being on the default VLAN. Now that we've configured GE002, we'll need to configure GE001 and GE003 the same way. We'll copy the configuration between the hierarchies to configure the other interfaces more quickly. Now, let's review our configuration changes to confirm that the changes we expect are being applied, and then we'll commit. Great. The changes we expect, configuring GE001 through GE003 as access ports on the default VLAN, is what we were setting out to do. So let's commit the change so we can validate the effects. Let's do a show interfaces terse to confirm the Ethernet switching protocol is active on the 3 interfaces. Here, we see that the active protocol on each of the 3 interfaces is the ETH switch protocol, confirming that our configuration was successfully applied. Now, copying the individual configurations between interfaces is a very valid way of completing this configuration, though the more preferred way would be one where we can make changes easily, as needed. Let's reconfigure these interfaces as an interface range. In case we want to make any changes in the future, we can do so quickly and easily. We can quickly delete configurations from multiple interfaces or other sections of the configuration hierarchy by using a wildcard delete. This matches all 4 of the configured GE interfaces on our SRX220. We'll select Yes here to review how this affects the configuration, though we don't want to commit this since our management access will be cut off on GE000. We see that all 4 of the configured interfaces were deleted from the candidate configuration. Let's roll back to the current configuration and delete the interfaces manually so that we don't interrupt our management access to the device and we can demonstrate interface range configurations. Now, we'll configure the interface range the same way we configure the individual interfaces. Just this way, it'll apply to all 3 interfaces at once. We'll commit the configuration and validate the ETH switch protocol is running on the interfaces. We see here that the interface range configuration has the same effect as the individual interface configuration. All 3 interfaces are running the Ethernet switching protocol. Let's go ahead and roll back to the individual interface configuration before we test connectivity between the routing instances on SW1. Now, if we take a look at our diagram once more, we have a configuration that this represents. Let's validate this functions as expected by pinging from the default routing instance of SW1 to the interfaces in the VR11 and VR12 routing instances. If the SW2 is configured as expected, all 3 interfaces will be in the same bridging domain, allowing them to switch the packets at layer 2 when the ARP request is sent and reply returned. we see that we've already learned the MACs of the interfaces on SW1. Let's move over to SW1 now and try pinging the routing instances from the default instance. So both of our pings were successful. Now let's clear the Ethernet switching table and repeat to validate the MAC addresses are being learned successfully. Great. We see the MAC addresses for each of the SW1 interfaces here, learning on the interfaces going to each of the routing instances on SW1. Now, let's move on to the second half of our lab activities. In this part, we'll be configuring static Ethernet switching table entries. This can be useful when combined with MAC limiting to enhance the security of your network, or to simply reduce frame flooding for frames destined to devices that rarely or never respond. So, table entries are rarely or never created dynamically. The eagle-eyed of you may notice this catch-all entry of the flood type. This is only present on devices which do not support the Enhanced Layer 2 software, or ELS, version of Junos. Since this lab is being demonstrated on an older SRX device which doesn't support the ELS version of Junos, then we see this catch-all entry. Now, let's configure these static MAC entries in our Ethernet switching table and see how this output changes. These entries are configured in the Edit Ethernet Switching Options Static VLAN MAC configuration hierarchy on devices which are running Junos versions prior to 12.3, as these older SRXs are. More modern devices will configure this feature under the Edit VLAN Switch Options Interface Static MAC configuration hierarchy. We'll set a different static MAC entry on all three interfaces on SW2. Here, we see that these static entries are present in our bridging table. They have the S flag, indicating they are static entries and will not have an age time listed because they will never age out of the table. That concludes our Layer 2 switching lab demonstration. The starting configurations, except for the management interface configuration for each device, are included with this lesson, so you may recreate the steps on your own devices if you'd like to follow along. I appreciate you working through this lab example with me. I hope that this lesson has been informative for you, and I would like to thank you for viewing.